Hello everyone, we're going to talk about the electrolysis. In this chapter, we will understand what is the meaning of electrolysis, how it happens, and we will also understand the basic idea in which kind of substance basically electrolysis happens. And we will also understand how many types of electrolytes are, and we will also try to differentiate between the metals and electrolytes. So let's start with what is basically electrolysis. If you're seeing the word electrolysis, so it is basically made up of two words. It is made up of two words. The first word is electro and another word is lysis. You can see this. So lysis means something, which is basically we use this in mostly in biology, which means disintegration, which means to break something up. Okay, so it is a breaking up something or dividing into the pieces. And electro means is basically it is related with the electricity. So electrolysis moreover is a chemical process. Basically we bring about with the help of electricity. So it's a chemical process that we do with the help of electricity and we break the component. Okay, so you can see electrolysis basically is opposite of synthesis reaction. The synthesis in the synthesis reaction, if you have seen this, what happens when the two substance combines or form a complex substance like AB. But in the electrolysis, it's just opposite. Here, the complex substance will break into simple substances. But here we do with a lot of things, like we do with the heat or we do with something else. But here we will do with the electricity. So basically, it's a chemical reaction where electricity is involved. So we can also say the electrolysis is a electrochemical reaction. It is electrochemical reaction. Okay, so I hope the idea is clear. Electrolysis means a breaking up of substance with the help of electricity or the chemical reaction that we are bringing about with the help of electricity. So this is the idea basically electrolysis. So where we do electrolysis? We do electrolysis on electrolyte. And if I'm seeing it is basically happening because of the electricity. So that means there will be flow of charges. And many people having the confusion whenever the idea comes in their mind of electricity, they think it is just a flow of electron. But it is partially right because electricity also happens whenever the proton is flowing, or even if the positive ion or negative ion is flowing, moving in a particular direction, drifting in a particular direction, it contributes the electricity. So this is the basically idea of electrolysis. We will understand the different type of material where the what kind of charge carrier they have. So first I'll discuss with the metal. Any piece of the metal, any piece of the metal. Basically metals are very electropositive. They are very electropositive. So what is the meaning of this one? That means the metal has the tendency to lose electron. Okay, and if they having the tendency to lose electron, that means they are having free electrons. Only they have free electrons. They don't have the free protons because the proton is stay in the nucleus of the atom. So with the neutron with a very high force, which we call this nuclear force. So basically protons are immobile. Okay, if the proton is moving, then entire atom will move. So in this case, electrons flow. So if you see the metal, simple metal, you're going to find that electrons flow in this. Okay, so basically in the metals, charge carriers are electrons. If you'll see the non-metals, so in the case of non-metals, there is a new condition because non-metals are electronegative, they are electronegative. Okay, that means they have the tendency to gain electron. So even if a non-metal have the uh, any free electrons, so they won't let it free. Instead, they gain it the free electron. Okay, so what will happen? They don't have the free electron like metal has, and neither they have the any positive charge free. So in this case, non-metals becomes completely non-conducting of electricity. So in this electricity, conduction of electricity is possible, but in this case, conduction of electricity is not possible because they are electronegatives. They gain the electron. They don't want to lose the electron, and if they don't want to lose electron, that means they don't have the free electrons. That's why they are. We also call non-metals are insulated because they don't allow the electricity to flow. So this is the idea of the non-metal. But electrolytes are a quite unique substance. Electrolytes are quite unique substance. How they are unique substance? Let's understand. Electrolyte. Okay, but don't go on this spelling. So maybe it may be wrong. So just understand the emotion that my teacher says all the time. Okay, so electrolytes basically is a kind of it is not kind of metals or non-metal. Basically, it is a compound. It is a compound, and this compound could be ionic. Okay, basically ionic means it is made up of metal and non-metal, and this compound will be covalent, which means it is made up of two non-metals. Okay, like covalent bond sharing of electron happens, and this uh, one metal gives the electron to non-metals, and this is how they form the ionic bond. So electrolyte basically is a compound, and if it is a compound, and we know the compound like NaCl you are seeing, so it's not going to conduct any electricity in the solid condition because this Na, which is basically positive, is combined with a negative, and they are attracted with a very high force. So in this case you're going to see that they're not going to conduct electricity. But what will happen if you dissolve in water, or you just heat it up so that it will melt down, so we call molten state. Okay, so both in the both condition, what is gonna happen when you're dissolving in the water, then NaCl will form Na plus and Cl minus. Okay, and when you're taking in the molten state, their ions get free. Because of high energy, the ion gets free. Now you can see in this case you are having over here as positive charge, negative charge, positive charge, negative charge, and they are mobile. That means they can move. So this negative charge will basically, if you take the uh, if you keep them, suppose if you're keeping over here Na and Cl, okay, and you're keeping the positive terminal over here and this side is a negative terminal, so sodium will start moving this was towards a negative, and chlorine will start moving towards a positive. So both of the basically these ion, they are charged particles, they both of them will contribute the electricity. So in the case of metal, if you remember, only electrons, the negative charge was the charge carrier. But in electrolyte, this positive and negative both are the charge carrier. So these basically difference between the metals and electrolytes are, we can say the metals are basically metals. They have they have just free electrons. But in the case of electrolytes, they have the both positive and negative ion. But in the case of metal, it can conduct electricity in the solid condition. In the case of electrolyte, either you have to take in a soluble if they are dissolving in a water, or if it is not dissolving, then you can take also in a molten state. So basically, either you have to take in a soluble molten, so it can't conduct electricity in the solid state, because in the solid state, like I told you, this Na and Cl, which is ionic compound, it is very solid, and their ions are immobile because they are very attracted with a very high force we call electrostatic force of attraction. Okay, so they are basically attracted with electrostatic force of attraction, so we can't really say that they will move, or if they are moving, so both together they move, that is together they are neutralized. So in the case of electrolyte, we can conduct electricity but only in soluble or molten, because in this case their ions are free. Okay, and you see this one, metal doesn't matter if it is in the molten state or maybe in the solid state, in the both cases they will conduct electricity because they have the free electrons. Okay, now we will understand electrolytes. What kind of, how many type we can actually categorize the electrolyte. So basically electrolyte could be categorized into three category, or substance that can be categorized into three category on the basis of their conductivity. Okay, so first is we can say good electrolyte. good electrolyte. What is the good electrolyte? Okay, and then there is the poor electrolyte. We can say uh, poor electrolyte, uh, and the next one is non-electrolyte. Listen, all the one thing is there that all the covalent substance, they may dissolve in the water, but that doesn't mean they will be electrolyte. For example, sugar. Sugar is a kind of substance, it will dissolve in the water, but they don't produce any positive or negative ion. So if they are not producing any positive and negative ion, that means they're not going to do any kind of electrolysis. So in this case, sugar is, though it is a covalent compound, like I said earlier, the electrolysis happens in the ionic or covalent compound. So if covalent compound specific cases, there are so many covalent compounds that are not soluble in water. So in this case, we can say they are non-electrolyte because they don't produce this positive negative, or even though you're taking in a molten state, they don't have the ions. So we can say they are non-electrolyte because they don't have the positive negative ion. The positive we call cation and negative is a anion. Okay, so they don't have it. Now let's see this one, good electrolyte. So good electrolyte is basically having a degree of ionization very high. So what is the degree of ionization? It is basically total number of molecule you have taken and total number of molecule has been uh, broken down. For example, you have taken, suppose you are taking NaCl or KCl, NaCl you are taking, and you have taken 100 molecule of NaCl. So total molecule you have taken 100, and suppose in the 100 molecule, 90 molecule of NaCl has been dissociated. Now you have to be very careful over here while I'm saying dissociation. In the ionic compound, dissociation happens, and in covalent compound, ionization happens. Now, what is the meaning of dissociation? Basically, ionic compound, they already exist in a form of ions. Okay, so you just breaking down, then you'll get the Na plus and Cl minus separated. They're already in the form of ions. That's why we're calling ionic bond. But in the case of covalent bond, like HCl you're taking, okay, and you're dissolving in the water. So you'll get H plus and Cl minus. So basically in the covalent bond, HCl was not in the form of ion, but it become only the ion when you dissolve in the water, which produce the cation and anion. So we can say that ionization happens only in covalent compound. But which kind of covalent compound? Polar covalent compound. Remember this one. So polar covalent compound basically are electrolytes. Okay. So now we are taking like this one we are taking, which is degree of ionization is higher. So that means when you're dissolving any substance, so they will produce a large number of ions. Like in this case, you can see this one is producing large of number of ions, and you connected this with the circuit completing. Okay, so this basically solution got so many free ions. So when you're applying the potential, this charge will start moving, negative will start moving towards positive, positive will move towards the negative, and the ball, oh sorry, a bulb will glow very brightly. Okay, and in the case of poor electrolyte, we call this weak electrolyte, we call this one a strong electrolyte also. So in the case of weak electrolyte, a poor electrolyte, we have the degree of ionization very low. For example, if you're dissolving this H2CO3, okay, so you'll get very less amount of H plus ion and CO3 minus 2 ion. Okay, so you'll get very less amount of ion in this case. So less number of charge carrier is there, so less amount of electricity. Now you're completing this, when you're completing this circuit. Okay, so what you're gonna see in this case is that bulb will glow very dimly. It will not be very bright. Okay, because charge carrier over here, so negative charge is very low. So hope you understood the difference between the electrolytes and poor electrolytes. Always remember one thing, that a strong electrolyte or the good electrolyte, basically they all are all ionic compound. Almost all ionic compound are a strong electrolyte. For example, NaCl, KCl. Okay, these are the very strong, and also uh, like strong acids, which is the covalent compound. A strong acid, they are very good electrolyte. Like you can say HCl, H2SO4, they have the degree of ionization very high. So if the degree of ionization of any substance is high, it doesn't matter if it is acid or base, okay, or even the salt. So we can say they are strong electrolyte because the degree of ionization says that, or degree of dissociation says that it's going to produce a large number of ions. So all the strong acid or the strong base, everything is very strong or good electrolyte. Remember this one. What are the poor electrolytes? So we will say when the degree of ionization is less. So for example, weak acid has the degree of ionization very low, or weak base has the degree of ionization very low, like NH4OH. It is a weak base. Okay, so degree of ionization is very less. So they're gonna be weak electrolyte or poor electrolyte because they produce less number of ion. They produce less number of ion. So, class, today we have understood in this lecture that what is electrolysis. We have understood that electrolysis is basically it is a breaking of substances. Okay, it is a breaking of substance with the help of electricity. We're going to understand in the next lecture in a very detail, and we will also understand that how electrolysis is just and process of opposite process of uh, chemical bonding. Okay, and then we will also understand electrolysis is a redox reaction or not in a very detail. Then we have understood the difference between the metals and electrolyte, and then we have understood the different types of electrolyte: a weak electrolyte, okay, a strong electrolyte, and non-electrolyte on the basis of degree of ionization. Hope this lecture is useful for you, and hope so you'll keep watching. Thank you so much.